molecular formula. Al2O3. Right. So once I set the molecular formula and I click finish, it will automatically calculate the molecular weight. Okay, but for all these other properties at the top, we're going to leave them as they are, like default for the ones for water, because we are not going to be specifically using them in the simulation. What we are mostly interested in is to set the molecular formula as well as having the right molecular weight and the category we want the component to be. Right, so once I've created this, I click finish. Right. So I've only created it, I haven't added it yet. So here you can see now the aluminium oxide is there, and it's showing you that it has been created for this simulation. Then I click this arrow, and then it moves automatically to the right. So we have created aluminium oxide. So we're going to do, first we check that if the compound is not there, then we create. Right, we've done aluminium oxide, then we also need calcium oxide. Then calcium oxide, you have these two, this one, then you have this one. So I'm going to choose this one. And also remember, before, you can also view the properties. For example, for this calcium oxide, if I go on edit compound, already there are properties that are there which are internal. So if I go on, I can check, for example, molecular weight. If I click here, okay, I just cancel this. Okay, so as I was saying, if you go to edit compound, you can even change a compound that is already there in the components library. If you want it to have a certain molecular weight, if you want it to have a certain molecular formula, you can override what is already there. But for now, we're not going to do anything. Since we already have this compound, I'm going to select this. We now have calcium oxide. Then we also need iron oxide. I come here, iron oxide. Right, iron oxide is there. This one. You're going to select it. Then potassium oxide, K2O, and right, potassium oxide, there's no K2O, it's potassium carbonate, potassium sulfide. Right, so we need to create potassium oxide. Right, create compound. Right, what's the name? K2O. Right, create for oil streams, suspended solid, set molecular formula, K2O. Right, then finish. Right, then I'm going to look for where my potassium oxide is. There it is. I'm going to select it. Then lithium oxide. So I'm just listing them in the alphabetical order. The first is with aluminium oxide, then calcium oxide. So now we check for lithium oxide. Do we have lithium oxide? Oh, we don't even have a lithium compound. Okay, so we need to create lithium oxide. So we need to create compound. Right, Li₂. And create for all streams, and then set molecular formula, Li₂. Let's say finish. Okay, there is our lithium oxide. There is our lithium oxide. Right. Now we're going to look for magnesium oxide. Right. There is no lithium oxide. The F. Then the calcined ore, the last compound, the last component. No, we still have sodium oxide. So sodium oxide. Let me check for sodium oxide. No, we don't have sodium oxide. So we have to create sodium oxide also. Then create 4 streams, set molecular formula. Na2O, then finish. Right. Then where's the sodium oxide? This one. Right. Then the last one is silicon dioxide. Okay, we don't have it. Okay, so we're going to create it. Create compound. Right, what you want is SiO2. And create 4 streams, set molecular formula. SiO2. Right. Then finish. Right. And then we're going to add it onto the selected components. Right. So for the calcined ore, we have listed all the different oxides that are present, as shown in here on the technical sheet. These are the different components. Right. So now that we have the different components, we now move on to the sulfuric acid. Right. So the sulfuric acid already we have water. So if you check, we have this one, sulfuric acid concentration 98%, and 2% is water. Then for this one, since it was calcined prior, there is no water available. So which means for the sulfuric acid we have 2% water. So already we have added the water component. This one, the liquid. So now we need to add the sulfuric acid. Okay. So if I come here, up S, and then I'm going to look for sulfuric acid. Right. There is the sulfuric acid. And then you select it. Aqueous. Right. So I have now added the components for the water, the sulfuric acid, then the calcined ore. Right. So basically, for the first part of the simulation with all the components we need, right? Then I'm going to, now the next thing we need is the temperature. So I'm going to select temperature. Right. So for now, we are now set to run our first simulation. So I'm going to click next. Right. Then we have derived variables. Right. So what derived variables are? You can create basic, calculations you want based on the components you have listed. And we're just going to show you an example. Let's say create. Let's say I want to know what the percentage in terms of lithium oxide will be. So I'm going to say percent Li₂SO₄. Right here to give you different scenarios. Here there's a constant, whether it's a ratio, it's a product, it's a linear. Let's say it's a ratio. Then I click OK. Right here it's going to give me this where I have to define the ratio equation, which is going to calculate percent Li₂O, right? So let's say percent Li₂O, we are going to say is Li₂O, the tonnage in the divided by percentage, sorry, the total flow of the whole stream. So is the tonnage of lithium oxide divided by the total flow, then multiply by 100%. I say finish. Right, here it's going to appear here as derived Li₂O percentage, and then it shows you the formula. So whenever you are going to be running your simulation for each and every stream, it is going to show you the percentage Li₂O for that stream. So you can create different variables which you want to monitor as you run the simulation, right? So I've only clicked this one. I'm going to be looking at this one. The next are the estimates. So the estimates are when you are starting the simulation, it has to have initial values. These are not the actual values you're going to be using, they're just initial values. So you don't need to really worry what is being shown here. So here I'm just going to say insert each and every value that is going to come out. I'm going to just say insert. When we are now starting the simulation, you now have the chance to put the actual values you want, right? Insert. After this done, say apply and finish, right? So this conical flask must always appear here. It shows you that you've defined your component, right? So now you can go to the next stage, right? So the next stage, we want to input what we call formats to the line. So basically what formats are, formats will be showing you certain properties of the stream. As you are running the simulation, you can't be going and opening each and every stream to see where maybe what your TPH is, or maybe what your percent solids is. So you can format this line so that when you are running the simulation, as it is running, you can see what the TPH is, you can see what the percent solids is, right? So if I click here, it will say create new line format, then I'm going to say new, right? So what I want to show in this simulation, we want to keep it simple. So what we're going to show, in the mass flow rate, which is the TPH, and then we want the percent solids, and then we want the volumetric flow rate, which is the cubic meters per hour. So you are free to choose whatever property you want to check. Okay, so how do I do it? Hash, and then so the hash, comma, hash, hash. Okay, so what have I done here? This is what my format will be for the first property I want to show. In this case, we said the TPH, so I'm going to say TPH in front of it. Let me put it in small caps, TPH, right? So what it shows is my TPH is going to be shown to 2 decimal places. You see these 2 hashes after the comma, it now represents 2 decimal places. So this is the first property I want to show, space in between, then hash again, comma, hash, hash, right? Then I say percent. The second property now is the percent solids. Again, the moment when I press the space in between the TPH and the next hash, already the first part is a property on its own, then after the space it's now a different property, then I have percent at the end. Then for the last property, space again, then I say hash, point, hash, hash, right? Then I say cubic meter, stroke, how do I put it? Okay, Alright, for now let's leave it to 2. I'm having problems with this keyboard, but let's leave it to 2. Okay, right. So now I can go down here. This one represents the first property. This one, the second property. So the first property, I go in here, then I choose what the property is. I want it to be a flow, right? Then the second property, I want it to be the suspended solids concentration. You have different properties you can choose from, but this one I want it to be the suspended solids concentration. This one, right? Then I say okay, right? Then I have to highlight where I want it to be. I want it to be on this stream, right? Then I click on that stream, right? I also want it to be on this stream. So if I come here again, and then already I can create a new one, but I want to use this one. I just click on place, and then I look for the stream I want, and I place here. Okay, I also want to place on this stream, but let me extend it a bit. So I just need to click the end, drag my mouse back to that point. I say okay. Then I want to place. Okay, I want to place it here on this output stream. That's it. Okay, right. So we've done the formatting for the different lines. Right. So we have created the flow sheet. The unit operation is there, which is mixing. The streams are there, and they have been named. They have been formatted. Right. We have defined the components, the stream chemistry. Right. Next, we are now going to run the simulation. So you might be asking yourself, but we haven't defined the streams in terms of the components and everything. Right, it will come as you go. So the next thing, you have this green button, specify and run simulation. Right, so that's where it comes. The specify part is now where you are defining the components for each of the different streams. Then you run the simulation. Right, so I click here to say update and save. Say yes. Right, so now we are now going to specify the properties for the different streams. Right, so I have this this pop out which says specification types. So you have different specification types. You have controllers, you have different specifications, you have networks, you have equation types, zero setting, direct setting, where you want to equate to another variable. You have your ratios, linear equations, all this sort. So what it says is specify the free variable water, right? For which stream? If I click show, that stream will blink, this one. So it wants me to specify what the water is for this stream. Right? Is it going to be a direct setting, or is it going to be controlled by something else? In this case, I want it to be a direct setting, so I can choose either this one or this one. They basically do the same thing. Okay, this one is a local specification, local variable using either a direct setting or a variety of equations. Then this one, multiple specification. Right, so for multiple specification is you can layer these specifications on top of each other for the different components. Then when you are viewing them, if you just click on one of them, all of them will pop out. So this is the one we're going to use with the direct setting equation type. Then I'm going to say place. Right. So I can place it at any point on this stream. I want it here. Right. So then it's going to ask me what is the tons per hour for water in this stream. Right. If you come here for water, with none in the calcined ore, right? So here I'm going to say 0. Since it's 0 already, I click on finish. Right, then it's going to ask me aluminium oxide. Okay, so In this case, it's asking in tons per hour, but if you look at our composition, it's in what? It's weight percent. So based on the basis we are going to be using, we want it to be 100 TPH. So basically 100 TPH, if this is the weight percentage, then this then just translates to the actual tonnage that is in the feed. So if we have 14.2% for aluminium oxide, then it means converting it to tonnage, it's 14.2 tons. Yeah, so that's what we are going to be using. So going back to this, I'm going to put here 14.2. Okay, I'm going to say finish. Calcium oxide, again, same specification, direct setting, place. So I'm just going to place them on top of each other, just to make sure they align. And I click. Calcium oxide, it's 0.1 tons per hour. I'm going to say finish. Then I have iron oxide, direct setting, place. I'm going to place on top of this again, right? Here it's saying 0.9, finish. Now I have potassium oxide, place again, place here, right? Potassium oxide is 1.7 tons, click finish. Then we have lithium oxide, going to place here on top of this. How much is the lithium oxide? Is 3.4 tons. Finish. So remember, I am getting all the information from this. It's from this table. So to finish up, we have magnesium oxide. Magnesium oxide, I'm going to place it here. And then how much is the magnesium oxide? It's 0.5. I'm going to say finish. Then I have sodium oxide. What is sodium oxide? Sodium oxide is 0.7. Okay. Sodium oxide 0.7. I'm going to place it here. 0.7. Finish. Then silicon dioxide, I'm going to place it in this one again. Then 78.5. right, now I'm going to say finish. Right, it's going to ask me for sulfuric acid as well, but in this case it's the sulfuric acid stream. I'm just going to place it also on top of this one, right? And zero, I'm going to leave it 0. Finish. It's going to ask me the temperature of the stream. So the temperature of the stream, if you check, we had it at 60 degrees Celsius. Okay, so that's what we're going to use, 60 degrees. I'm going to place it here. The default is 50. Let me change it to 60. Finish. Right, now we are on the next stream. Just asked me the first stream. Now I'm going on to the next, onto the second stream. If I click on show, the stream will blink. Right. So we are done with the calcined ore. Now we are going on to the sulfuric acid. The sulfuric acid stream. Right. So it's asking us to enter the water, what the water going to be in that stream. right? So basically, okay, just hold on a bit. Okay, for our water, direct setting, then we're going to place in this stream sulfuric acid, concentrated sulfuric acid stream, right? So here I'm not going to specify the water in tons per hour, but if I click here, I want to specify it as a percentage, okay? Because the sulfuric acid, we're going to enter it based on a calculation, the stoichiometric requirement. So we also want the amount of water to be determined by that stoichiometric requirement. We're not going to enter the amount of water. What we are going to enter is the aqueous solids concentration, aqueous dissolved solution concentration, right here. So what do I want it to be? I want it to be 98%, because remember, if you come here on our technical data, H2SO4 concentration is 98%, right? So we want the concentration of this stream in terms of the aqueous part, like what in terms of the sulfuric acid in this stream, we want it to be 98%. So it's going to add water until we have a concentration of 98% sulfuric acid, right? So that's the specification I'm going to use here. I'm not going to enter tonnage for water, right? Then I say finish, and it's asked me for ammonium oxide, and then just like we did for the first stream, just lay it on top of each other. Now I'm going to input 0 because we don't have any oxide or any other compound in this stream besides water and sulfuric acid. So here, calcium oxide 0, iron oxide 0 as well, finish, potassium oxide 0 as well, then you say click finish, lithium oxide, I say place, and then finish, magnesium oxide, place, finish, then sodium oxide, I'm going to place it here, finish, and silicon dioxide 0, finish, right? Then it's asking me for sulfuric acid, right? So for sulfuric acid, before we input anything, we have these sets of reactions, lithium oxide reacting with sulfuric acid, ammonium oxide, basically the different oxides that are in our calcined ore reacting with sulfuric acid. Then we have the different MRs, the mole ratios. Then this one is basically a calculation of how much sulfuric acid you need for every ton or for every kg of lithium oxide. So for every kg of lithium oxide or for every ton of lithium oxide, I have to multiply the tonnage by this factor to get the stoichiometric requirement of sulfuric acid, right? So this is the one that then adjusts. If I want 100%, if I want the exact stoichiometric requirement of sulfuric acid depending on the amount of lithium oxide, then I have to use 1, which is 100. So if I want to use, now in our case it's saying 20% excess, so we now need to use 1.2, right? So by 1.2, which means for every ton of lithium oxide we are going to use times 3.939 for sulfuric acid. Okay, it basically just does the same for all the different compounds, but in our simulation it specifies that it's based on lithium stoichiometric requirement only. So all these other reactions, we are not going to be accounting for the stoichiometric requirements in terms of sulfuric acid. We are only going to be using for lithium. So we have to take note of this factor 3.939. We're going to be using it somewhere, which we're going to be seeing next. Right. If I go back to CADSIM Plus. Right. So I want my sulfuric acid, right, to be based on a linear equation. Right. I want it to be based on a linear equation. Right. So I'm going to click on this one, the local specification. I'm going to say place. Right. I'm going to come into this stream. Okay. And I click here. Right. Then it's going to ask me to add a term. I want to add a term. Right. Then I'm going to click in this stream now. I'll explain. Okay, so what is happening is I want to specify the amount of sulfuric acid in this stream. Okay, that is why I have this local specification here. Then the add term is coming to this stream. I want to specify the sulfuric acid based on the tonnage of lithium oxide in this stream. That is why I have this specification on this stream. So here it's saying H2SO4 tonnage is equal to what is in the feed, this 101. Right, I go to the drop down, I look for lithium oxide, this one, and I click on this one, multiplied by what? Multiplied by that 3.939, that factor. Okay, so H2SO4 appears in this stream is equals to lithium oxide in this stream multiplied by 3.939. Then I click finish. Okay, then it's going to ask me for the temperature. I go on the multiple specifications and I go and click here, and I'm going to use 25 degrees Celsius. I say finish. Right, then for this acid mixer, it also has its own specifications which have the volume, but we're not really going to be focusing on this one. I'm just going to place it anywhere on the mixer here, and just keep the default that's there, then say finish. So once it is finished, it will then prompt you to save, and I'm going to say yes. Right, now everything else disappears, it's like that. So now the next stage is to run the simulation. We have created the flow sheet, we have entered the streams, we've entered the unit operation, the components, then we have specified each and every stream. Okay, so now what's next is to run the simulation. This is the run button. Right, now the simulation is running. So what we can see from here, for this stream, calcined ore showing you is 100 TPH, 100% solids. Okay, for your concentrated sulfuric acid, it is calculated that the requirement is what? 13.67 tons. There are no solids in, then everything goes into the mixer. It's mixed. What comes out is 113.67 tons per hour. It's 87.98% solids. Okay, so now we have run our first simulation. Okay, I can click on the stream. Let me click on this one. Right, it shows me the different properties of the stream. Your water, you have 14.2 aluminum oxide, 0.1 tons per hour calcium oxide. You have your temperature at 60, the total mass flow 10%, volumetric flow, you have the density, you have the aqueous dissolved solids concentration, energy flow, different properties which you can see. Then that derived variable, the percent lithium oxide, is also showing 3.4%. Okay, if you come to this stream, this sulfuric acid showing you that your water is 0.27%. Remember, we didn't specify in terms of the amount of tons, we just specified that we want the concentration of sulfuric acid to be 98. So it calculated the amount of water, it calculated the amount of sulfuric acid required, it calculated the amount of water. So if you check here, aqueous dissolved solids concentration, it's going to tell you 98%. Okay, and you also have the different properties for this stream where you have no solids, it's just water, sulfuric acid. Okay, so once everything has been mixed, you get this stream which now have water, aluminum oxide, your acid, everything is there. If you check dissolved aqueous, it still remains 98% in solution. Then that 87.97, this is suspended solids concentration, and then your percentage lithium oxide concentration, percent lithium oxide is now 2.99%. Okay, so now we have run the first simulation. So as it is currently, it will be running. So I'm going to click pause here, right? Then I'm going to come here on file, and I'm going to say save start file. So by saving start file, whenever we're going to be running this simulation, it's going to be starting from the already what we have entered already, the specification, the conditions, everything. When you next time you're going to be running this simulation, it's going to start from those same properties that we have already entered. Okay, right. So for now, everything is in order. You can even check if you click here on these specifications, right? We are layering them on top of each other. So if I just click here, all of them will then come out. We're specifying in terms of the TPH for the different components. Here we have zeros. For the water we said 98. Everything is shown here. You can also check for this one. So you can also change even here. You can also change here. If you want to change your aluminum oxide, you can also change here as you are running. So once you change, everything changes. Let's say here 14.2. We want to change it to say 50. I say 50, then I apply. You see everything has already changed here. Okay, so I need to put it back to 14.2. Let's say apply. Okay, so this is the first part of the simulation, right? So now I want to go back to draw mode. This is the simulation mode. To go back to draw mode, you have to come here, right? And then it's going to ask me for this. Will be say, so it's going to save the file before returning to drawing mode. So I'm going to say yes. Right. So we've seen the first part. Now we need to go to the second part, which is now the kiln. Right. So on the kiln we have this part. So now we need to add a kiln. Okay. Okay, now we are back in draw mode. So now we need to input the next unit operation, which is the kiln. Okay, so for the kiln, I'm just going to extrude this line to this point. Okay, it's fine. Let's put the kiln in front here at this point. Right, so for the kiln, we're going to use the part, the reactor. Okay, so I'm going to come back to parts here, and then there's the reactor. Okay, so I want to use this reactor. I'm going to say insert. Okay, I want it where it is, and I'm going to say okay. So the input name, say sulphuric kiln. Okay, when you click OK. Right, so this kiln, I want to move the name outside here. Okay, let's just do the same for this one, just to give the unit name outside. Right, so I have a reactor. So now for the reactor, this is where we are going to have the reactions. For this one, we're just mixing here, going to be having the reactions. Okay, so let me just move this here a bit more to the left. Yeah, okay, so just after the reactor, I want to add something, splitter. So I'm going to click here, then I'm going on here where you want to draw a polygon. Okay, and I want something like this. Okay, input polygon name, and let's say chest. So, okay, press escape. So I want to move this chest name outside. Okay, now I want to change the color to number 9. Okay, apply. Okay, right, so this is a gas splitter. After the reaction in the kiln, we are going to have some off gas, so I want to split the off gas at this point. Okay, so here, and I need to input a stream from here. Okay, just have it come here, then here. Okay, then I'm going to have the roast product from here. I need to go this way, then it goes down here. Okay, so we have the kiln, then this chest is just a splitter. So chest is just a default part in CADSIM Plus, and then you can use different keywords for what you want it to do, but for now we just want it to split, and we are going to be using the specifications for the splitting, so we are not adding any keywords to it, so we are going to leave it as it is. Then it has 2 outlet streams. This one is for the off gas, this one is for the roast product. So let me input the stream names. This one, let's name it kiln off gas. Okay, it's fine where it is. This one, let's name it acid roast product. Acid roast product. Okay, right, so we've named the streams. This is the off gas. Okay, right, so now before we go any further, if we check here, module help, right, you have your reactor, and it shows you. So I'm going to come again on this index, and I'm going to type reactor, because I want the module parameters. This is the module description. I want the module parameters, right? The reactor, okay, number of streams, 1 inlet, 1 outlet. Okay, so there are keywords that you can use, the unit keywords. These are the ones I'm interested in, and we have this one, the reactions. Yes, the reactions. So in the kiln we have different set of reactions that will be happening. Okay, these reactions. Okay, so we want to input these reactions into the simulation, right? Okay, so this one, drawing module. Okay, close this. Okay, then I'm going to say okay. Right, for me to be able to have reactions, okay, multiple reactions, I'm going to click here on the process text. Okay, and I'm going to come into this reactor, then click on this reactor. Right, say add text to polygon. Okay, I'm going to say reactions. Okay, I'm going to say okay. Right, I want to drag these reactions to this part. Okay, I also want to add another one. Okay, no, I don't want it on the process line. I don't want it on the process line. I want it on the polygon. Right, add text to polygon. I'm going to say temperature. Click OK. Right, so I'm going to drag this inside here. No, the reaction is fine. Okay, let me just drag this. Okay, let me zoom in a bit. Right, zoom in again. Okay, go for reactions and drag it to this point. Okay, so for these keywords, I'm just going to change the color also to this grayish color. Apply for the temperature. I'm also going to change it to this one. Okay, so these are the keywords. 2 keywords are going to be using for them. For the reactions, one, it's okay as it is. For the temperature, I want it to be a variable, so I'm going to change here. A variable unit cast, so I'm going to put it as a variable and say apply and okay. Right, then for my lines that I have zoomed in, I just want to change the line type. Here it's minor process, so I want it to be major process. Then say two lines. Okay. Right, if I zoom in a bit, you can see they have changed. They're not different from these ones, so I want to change this one, this one, that one, and this one also. I want them to be major process lines. Right, say apply process lines. Okay, right, so zoom out a bit, zoom out again. Right, so this is where we are with our simulation. So I'll come again here on the specify and run simulation. If I click, it will prompt me to save, and I'll save. Right, it's saying volume for what? If I click, showing me is the kiln. Right, so I'm going to click here, direct setting, place. Right, I'm going to place it here, keep the default. Right, it's going to say reactions. Right, I'm going to place inside. Let me place it inside the kiln. This is where the reactions are happening. Right, so you have this interface which says list of reactions, where you have available reactions, where you have selected reactions. Okay, right, so where we are now is where we are going to be setting up the reactions. Right, So I want you to click cancel. Okay, then we are now back in draw mode. So I want you, what we are going to do is we are going to come here, click here, okay, then click edit. See the stream definition, then I'm clicking the edit. Right, so what we now have to do before we can enter reactions, if you come here, is we have different products, right, but these products have not been yet defined in our stream chemistry. So we now need to list these products in our stream chemistry before we can go for reactions. Okay, right, so that's what we're going to be doing next. Right, so the first compound I want to add from the reactions, it shows that we're going to be having steam, right? That water product is coming out as steam because of the reaction temperature. So if I go to gas, I have steam here, then I'm going to select steam. Okay, right. The next, I have the sulfates. My aluminum oxide is going to react with sulfuric acid to give me aluminum sulfate, okay, which will be solid. If I come here, solid, then I look for aluminum sulfate, there it is, then I select it. Okay, and then next I have to look for calcium sulfate, calcium sulfate, there it is, this one. I'm going to select it. Then I need iron sulfate, this one, the solid, select it. Then I need what's next, potassium sulfate, this one, select it. Then lithium sulfate, there's no lithium sulfate, so we're going to have to create a lithium sulfate compound. Solid, create compound, then I want Li₂SO₄. okay, create for all streams, set molecular formula Li₂SO₄. right, already strict suspended solid. Okay, but I also want a lithium sulfate component but in aqueous phase, so I'm going to tick here. What it does is it's going to create lithium sulfate as a solid and as aqueous, so that we don't have to redo the process. So once you say aqueous, it changes here. Now needs a cation, needs an anion. For the cation, it's Li. For the anion, I'm going to say SO4. Sorry, SO4. Right, for the Li cation, we have 2. It was Li2, so F2, SO4 is 1, so we leave it as it is. Right, then for this one, right, now it is changed to 1, which is okay. I'm going to say finish. Right, and I'm going to check for the lithium sulfate in the solids. Here it is, and I'm going to select it. Okay, then I'm going to look for magnesium sulfate. So what I was telling you before I go to magnesium sulfate, we can check here and check aqueous, then we check at the bottom. Right, you see there's also a lithium sulfate aqueous that has been created. Okay, so we go to solid. We now need magnesium sulfate. Magnesium sulfate. Okay, this one. Right, select it. Then we need sodium sulfate. Just this one. Then select it. Right, these are the compounds that are going to be formed in the kiln. Then I click finish. Right, so what's going to happen is when you go to specify right? It's now going to start again from the first stream because we have added new components into the model. So I have to specify what those components are in these streams as well. So we're just going to be doing the same process we did in the first place. Overlay on this one, right? Still 0 because we are not adding any steam or any other compound, any sulfate in these streams. So I'm just going to put zeros. Okay, move on to the sulfuric acid stream. I'm going to be doing the same. Okay, so for that one is done. So now we are on the reactions part. Okay, we're going to place it inside the kiln, right? Then I need to create reactions. So here, okay, if you have this pop-up, go on create. Okay, and here you have this pop-up, then you go on edit reaction, right? This one pops up. So this one is the one that helps you to create the reactions. Okay, so the reactions, the first one, you have this one, aluminum oxide plus sulfuric acid, get aluminum sulfate plus steam, right? We're going to first enter this first before we go on to these two, right? So here, you come here, I'm going to say add reactant. Okay, default is going to put the first one, which is water, but I need aluminum oxide. Select aluminum oxide. I need another reactant, which is sulfuric acid. So I'm going to look for sulfuric acid. This one, sulfuric acid, right? I'm going to click here, right? Add product. The product, I need aluminum sulfate. Add product again, then I need steam, right? So I have this. So this one, if you look at the reaction, we have these three, that three also have to be accounted for. Stoichiometric coefficients here, I have 3, here I have 3. Okay, once this is done, I click finish, right? Here I have two things I need to enter. There's the heat of reaction in kilojoules per ton. The heat of reaction, based on what I have, it's 181. It's 1,810,000. So I'm going to copy that and come here. Okay, I'm going to paste that here. Then the reaction extent is 10. This is the reaction extent, 10%. Okay, so I need to enter 10 here on the fixed extent. You have two options where you can either use the kinetics or the reaction extent. The kinetics, you now need to enter the rate constants, the activation energy, but for now let's use the reaction extent, 10%. So now we've done this, and to click finish. Now the reaction is already there. So we're now going to do that for all the other components here. So once I need to add another one, just go on create, edit, add reactant. Okay, now we want what? We want calcium oxide. Right, calcium oxide is reacting with what? Sulphuric acid. Okay, this one, the product, if calcium sulfate and steam. Okay, the reaction is balanced. Yes, the reaction is balanced. Okay, we need this. Right, so since the reaction is balanced, reaction extent is 50. Okay, so I come here, the reaction is balanced, we say finish. Right, then this one, I'm going to say what? Paste. Okay, let's just say, forget about this. Right, this one is 50. So the reaction extent is based on the limiting reactant. In this case is calcium oxide. You can change to whatever you want based on the reactants, sulfuric acid or calcium oxide. For now, we want 50% of calcium oxide to react with sulfuric acid. Right, click finish. Okay, then I go create another reaction. In this case is iron oxide. Iron oxide reacting with sulfuric acid. Right, the products going to have iron sulfate and steam. Okay, so here I need 3 stoichiometric coefficient. Here I also need 3. Okay, okay, what happened to this one? Okay, okay, let me try to minimize this a bit. Try to minimize that a bit. Okay, so for the iron oxide, we copy this. Reduction extent is 10%. Then I paste this here, 10%. Then I click finish. Then I create another one. In this case is potassium oxide reacting with sulfuric acid. Okay, sulfuric acid. Then I add the product. Which is potassium sulfate. Then I add steam. Okay, coefficients are okay. Then I click here, finish. Okay, the rate of reaction. Rate of reaction is this one. Reaction extent is 50. So the rate of reaction, I input this one, reaction extent 50, the limiting reactant is potassium oxide. I say finish, and then I create another reaction, this time for lithium oxide. Okay. So edit reaction. Okay, let me cancel this. So this, I need to do a fresh one, create, right. And I have this. This is lithium oxide reacting with sulfuric acid. Then I need to add products, lithium sulfate, and another product, steam. Okay, the coefficients are okay. I say finish. Okay, then I need the rate of reaction. Reaction extent is 50%. So here, rate of reaction, this, and reaction extent in terms of lithium oxide is 95. So it's 95%. 95%. Okay, I click finish and create another one. This time is for magnesium oxide. It's magnesium oxide reacting with sulfuric acid to give us magnesium sulfate and steam. Okay, coefficients are okay. I say finish, right. Rate of reaction is this one. Okay, reaction extent 50%. 50. I say finish. Okay, now for the last reaction, create, edit reaction. Okay, I need to cancel that as well. Again, try to create a fresh one. Okay, cancel, create, edit reaction, right, edit reactant of sodium oxide reacting with sulfuric acid. Okay, for the products, we have sodium sulfate and steam. Okay, I click finish. Then I check the rate of reaction. Then the reaction extent is 50. It's rate of reaction. I paste that. This one is 50. Okay, and finish. So we have these reactions now. Different sets of reactions that are going to be happening inside the kiln. Silicon dioxide doesn't react, it's inert, so there's no reaction for that. Okay, so once I'm done with this, I click on finish. Okay, now I need to specify the temperature. Click on this one, then place. Okay, I want to place it there. What is the temperature? Reaction temperature is 250. Okay, if you check on the technical data, you have this one, 250. Okay, So the 250, then I click finish. Right, then for the chest, just going to ask me for the duty. Don't worry about it, just place it anyway. Okay, I want to place it here. Yeah, here. Just say 0. It's going to ask you for heat loss. Okay, just put it there as well. Okay, don't worry about it. Right, now it's going to ask you to specify between the two outlet streams. What do you want to be? What do you want here? What do you want here? Okay, right. Okay, so I want to specify the water. Saying you can specify either. So I'm going to place direct placing on this one. Okay, right. For water on the off pass, I want it to be 0, since it's only steam that you want in this line, not water. So I'm going to specify 0. Then for the steam now, I want to equate to another variable. Okay, so I'm going to use this one again. Let me place it here. Okay, right. Okay, let me re-choose. I prefer using this one. Let me use this one. Okay, yeah, this one. Then it's equating. Then I'm going to place it here. Okay, right. Then I'm going to add a term, right, on this line. That's coming from the kiln direct, right. So I want the steam that's coming from here to be equal to the steam that's coming from that one. So what basically it means is the steam that is coming in this stream is the steam that's coming straight from this kiln. Every bit of steam from the kiln is supposed to go into the stream. Then now I have to specify the steam in this one. Okay, let me put a direct setting and let me place it in this one. Right, the steam in this one I want it to be 0. Okay, so what I have done is the steam that is going, all the steam from the kiln is supposed to go in this stream. That is why I have this specification that's equating the steam here and the steam here. Then the steam in this one, I want it to be 0. That's why I had the specification for 0. Now I need to specify for all the other components, but I'll be specifying for this stream because I know this one is only steam, so all the other components will be 0. Okay, so I'll be having direct setting on the multiple specification for this one overlay here, and everything is going to be 0. Okay, temperature. Okay, let me just use the reaction temperature to 50. Right, so we have entered everything. We have saved, we've entered the reactions, we've specified the outlets here. Now we can run. Right, so since we saved that startup file, whenever you are running now, it's going to load from the start file. Okay, so now our simulation is running. So I just want to go back to draw mode so that I can format these two lines. Okay, I want to place let me place this one here. Okay, right, and for this one I'm going to create a new one. I'm going to say new. Okay, hash. Okay, it's tph. Okay, and then I want hash. I'm just going to put a v. Okay, okay, that's cubic meters per hour. Okay, so this one I want it to be the total flow, stream flow, tph. This one I want it to be the volumetric flow rate in cubes per hour. Okay, I'm going to say okay. Then I'm going to place it on this stream. Right, then I'll run to save, then run the simulation, load start file. Okay, right, so based on what we have this. Okay, the mixture of the acid and the calcined ore into the sulfitation kiln. We have the reaction, right? From the reaction, we have this stream that's going out, that is only steam, 9.53 tph. There's no other component in this stream. Okay, only steam. Then the product from the kiln, we have this one. Still have this aluminium oxide, calcium oxide. Okay, but it also now has these sulfates as well. Then we have sulfuric acid that's remaining at the temperature, and we have all the other components. It also shows you percent lithium oxide that remains, 0.16%. Okay, you can check on the specifications. This one is where we specify the zeros for all the other components. Okay, so that we can only have steam in this line. Okay, for this one it's specifying the steam is 0 in the temperature, and then this one is basically specifying amount where we are equating the steam we measure from this kiln outlet and the steam we want in this line. Okay, so we have done the acid, the mixer, we have done the kiln. You've seen how the reactions, we do the reactions, and then how we split the streams. Okay, so now we are going on to the last part of the simulation, which is now water leaching. Okay, so for water leaching, in this case we are going to use a reactor again, because we have dissolution reactions that are happening where the sulfates, the solid sulfates, are now turning into the aqueous form. Okay, so if I come here on my model, I want to add a reactor here. Okay, it's still in simulation mode, so I need to go into the draw mode. Okay, then I click here. Right, then I need to insert again a reactor. Okay, and set. Okay, it wants to go that way. Okay, I need to rotate it. Okay, this looks fine. And let me say okay. What do I want it to be? Let me say leach tank. Okay, right. I move the name outside. It's the leach tank. Okay, right. So I need another stream. Okay, we already have this stream from the leach tank, this one. Let me extend it to here. Okay, then I need another stream that's coming into the leach tank. Let me say from here. Okay, I click on the draw line and I want this stream into the reactor. Okay, so let me first format this, these lines. Let me just say okay. Let me zoom in again, zoom in again. Okay, so I need to do for this line, for that line, and for this line. Okay, I need to change from minor process to major process. Right, and I can zoom out. Okay, right. So now I need to name this stream. So this one is process water. Okay, remove the name. Right, then I also need to name this one. Okay, there's something I missed. Okay, there's something I missed. Okay, let me move. Okay, first let me shorten this line. Okay, then let me move this whole section. Okay, right. Okay, so before entering into the tank, I need to put another chest, which in this case it will act as a mixer. So if I click here, okay, this one, let me just drop down them a bit, yes, like this. Then here, click here. Okay, I draw a polygon. Right. Polygon name, let me say chest 2. Okay, because I already have a chest here, so I need to just use different names. Chest 2. Let me put them here. So this one is not acting. It's just acting as a mixer. This one was a splitter. This one was a mixer. So base, usually I want to use this when I have two streams or what, either I'm using a mixer, but in this case I have a stream that is supposed to go into the leach tank, two streams. So that it doesn't mess up with my reactions, I first mix the streams before going into the leach tank, so that in the leach tank I'm just focusing on the reactions only. That's the same reason why I had to use a splitter after the sulfatation kiln, so that it wouldn't mess up with my reactions, trying to specify which one is going into which. Here it focuses on the reactions only. The products are then split after the kiln. The same here, we have two streams, they mix, then they go into they do the reactions. Okay, so here, okay, my process water is going here, so now I need a stream from here that is now going into the leach tank. Okay, right, let me just put this yeah, major process. Okay, right, now I need to name this stream. This one is process water, so this one is the leach product. Okay, and the leach product, the tune of gas. Okay, right, and then we can also add the formatting. So here I'm choosing the first one. I want to place it here, and this one I want to place it okay, it's coming out in that orientation, but I can change it. Just click on the format and come here and you put 0. Right, now it's horizontal, so I want to drag this, it comes down here. Right, then I also need for this one after the mixing. Okay, place here, I want it to be down here like this. Right, yeah, I think for now I'm satisfied. Okay, right, now we need to input the keywords, the reaction, and the temperature. Okay, so here I go text for polygon, then I say reactions, then I say okay. Okay, and I just change the color to number 9. Okay, then I add another one. Right, I need temperature. Okay, say okay. Right, let me just move it up to here. Okay, it's fine. Let me change the color again to number 9. Then name into a variable. Okay, right, so that is done. Okay, so we go on to specify. Before we go to specify, right, what reactions are happening here? These are dissolution reactions where these solid sulfates are being leached into aqueous sulfate. So we now need to go again to the stream chemistry, and then we need to add these components in the aqueous form. Okay, so if you come here, if I okay, right, I click on this flask, I click on edit. Right, this one comes up. Right, I need to go to the aqueous and check for my aqueous sulfates. First one, aluminum sulfate, here it is, select it. Second one is calcium sulfate, here it is, select it. The third one, iron sulfate, select it. Potassium sulfate, select it. Iron lithium sulfate, it's at the bottom since we created it. Here it is, select it. Magnesium sulfate, here it is, select it. Then last one, sodium sulfate, here it is. Okay, after that click finish. Right, we have added the components for this next set of reactions. Now we need to specify again the input streams. Okay, right. So here is what we're going to be doing. Click on specify and run simulation. We save the file. Then we have to specify this stream, the process water. Okay, so for the process water, we're going now to use a controller because we want to add water up until this stream achieves a percent solids of 38%. Okay, so for that we now need to add a controller. Right, so here you select controller. Okay, manipulate a mass component or a flow with a PID controller. A set point or equation will be required for external variable. For now we're going to use a set point. Right, I placed a controller. Which stream do I want to control? I want to control this one. Okay, the water stream. Right, based on what? Right, I select this one here. Right, what do I want? I want to add water up until the suspended solids concentration, this one, okay, is 38. Okay, and click finish. Then for steam, right, we have no steam in this line. We're going to use direct setting. Place here 0. Okay, so all the other components here, they're going to be 0. Only water. So we have already used a controller for that one. Okay, the temperature of the stream is coming in at 25 degrees. And I click on finish, then it's showing me aqueous. For which one? Okay, calcined ore, aluminum sulfate. Okay, something happened here. Okay, I want to place it here. Yes. Okay. Right. So I'm just specifying the additional components we just added, the aqueous sulfates. So I have to specify for all the other streams. Okay, the last one for this stream. Right, then I have to specify for the off gas. Again, it's zeros as usual. Okay, the last one, sodium sulfate. Okay, then I have to specify the duty for this chest. Okay, 0. And then specify the heat loss. Yep, we use another 0. Right. Then it says specify the steam for this stream. Okay, just place it here and it's 0. Right. Now we are on to the leach tank. Say specify the volume. Specify the volume is 100. Just leave the default. Right. Then specify the reactions. Right. I'm going to place the reactions inside. Okay, no reactions. I'm going to create edit reaction. Right, add reactant. The first one, it's aluminium, the sulfate. The product is now the aqueous. Right, the aqueous one. And you click finish. Reaction extent. I want it to be 100%. Heat of reaction. What do I have for heat of reaction? I have this guy. Okay, I copy that. And okay, create another reaction. This time is for calcium sulfate. The product aqueous calcium sulfate. Okay, click finish. Reaction extent 100. Heat of reaction. Okay, and click on finish. Next one. Product potassium sulfate, then with 100% reaction extent. Then for the heat of reaction, this one. Okay, there's this. Then click finish. Okay, the next set of reaction is for the lithium sulfate. Lithium sulfate, aqueous 1, finish, reaction extent, 100%, then heat of reaction, okay, heat of reaction, there you are, test, and finish. Then I create for magnesium sulfate, this one, then the product magnesium sulfate aqueous, and finish, reaction extent 100, then the heat of reaction, going to use this one. Okay, then we have this, that, finish. Right, then last reaction, let me cancel this, this reaction, let me cancel that, this reaction, and reactant, it's sodium sulfate into sodium sulfate aqueous. Right, so I have that, then I click finish, extent of reaction, it's 100, 100, then heat of reaction is, I'm going to copy this one, Right, this is my heat of reaction. Right, okay, so I'm done with the reactions. Click finish. Right, then it's asking me to specify the temperature. Okay, so I place here. Okay, what is the temperature? Temperature is specified as 25. Okay, so we'll specify it here, 25. Okay, then click finish. Right, now everything is fine. I save the file, click yes, then I run. Load start file. Okay. Right. So now the simulation is running for all the unit operations. Here I have 159 tons per hour processed water that is adding to this 104.13 tons of acid roast product. They mix. Then from there we have this 263.16 tons per hour at 38% solids. That percent solids we use the controller on the processed water. So now this controller is controlling the amount of water entering so that we achieve 38%, and the 38% goes in for leaching. Okay, now for leaching we have the reactions. These ones 100% dissolution. Okay, then we have the leach product. Now for the leach product, what do we have? We still have these solids, the unreacted oxides from the acid roasting step. Then now these ones, as you can see, the numbers, they are now very small. Eventually they will become zeros because we've converted every solid sulfate into these ones, aqueous sulfates. Now we have challenges for this. Okay, so basically that's what is happening. If you look here, the controller, okay, it's controlling 38%. So you can change here. For example, let's say I want it now to be 45 instead of 38. Okay, then if I apply, I can see that my water is changing. I can see that my percent solids has increased. Okay, so let me keep it 38 as it is, then I apply it like this. Okay, then here this one was for what? This one was for steam, just specifying steam to be 0. Then this one was for all the other components, specifying everything to be 0 in the processed water stream. Okay, so for module 2, yes, that's what we were focusing on, building up this simulation. So we successfully built this simulation, 3 unit operations. We have mixing, we have reactions happening in a kiln, and we have leaching, which is also a reactor, and then putting all these streams, linking everything with streams, then specifying each and every different stream. With this one, that was calculating the amount of sulfuric acid required based on the lithium oxide content. We have this controller that is calculating the amount of water, controlling the amount of water going into the leach tank so that we achieve 38% solids content. We have also this one, which is specifying that the amount of steam in the off gas should be equal to the amount of steam exiting the kiln. Okay, then we have different specifications. This one was saying that besides the steam, nothing else should be there in that stream. Okay, then also I've shown you how to add components, how to edit components, as well as how to create your own components. We've also seen how for each unit operation you add the use of the keywords. If you want to have reactions, you type in the word, you type in the text for the polygon as reactions so that you can have multiple reactions in your unit operation. using this chest also as a splitter of gas, and then you have the roast product. Using this chest as a mixer, we are mixing processed water and acid roast into the leach tank. Okay, so I think for this module we have covered each and every step here all the way up to learning the simulation. Okay, thank you.